Now let us move on to a new topic in the semiconductor chapter, that is logic gates. A gate is either open or it is closed. So it can have only two states. So logic gates are the digital circuits made up of semiconductor devices such that either it can have a high state which is digitally represented by 1, or it can have a low state which is digitally represented by 0 based on some electronic logic. So that is the reason why, based on some electronic logic, if it can have only two states, such devices or such digitally logic devices are called logic gates. There are mainly three types of logic. One is NOT. NOT gate is represented by this symbol of a triangle and a dot, which says if A is the input, Y is the output. The function is called complement. Suppose A is 1, then Y will be 1 bar. It is called 1 bar or 1 complement. That value will be 0. Suppose if A is 0, then Y is 0 complement, value will be 1. So the truth table, here input A, here it is output. Here it is output. So this is, if output is complement of the input, so it is 1. If the input is 1, the output is 0. Next basic logic is OR gate, OR logic. So OR gate is represented by this symbol, where the function is A or B. It is having two inputs, A and B. A and B. So by looking at the output logic, if A is high and B is low, or if B is high, A is low, the output is high itself. A or B, any one of the input is high, output is high. Hence the name OR gate. So if we apply, if you write the truth table A and B, then the output logic is A plus B. We start with the lowest significant figures 0 0, then the output is 0, then 0 1, output is 1, 1 0, output is 1, and 1 1 high high, the output should be high. This is a OR logic and the truth table for that. Next, the basic logic is AND gate. It is represented by D, just represents, and a line having output line and two inputs. So the logic of this is Y is equal to product of A and B. If both A and B high, output is high. That is why the name AND gate. So if we write the truth table for the inputs A and B and the output A dot B now, starting with the lowest significant figure, lowest figures 0 0, output is 0, 0 1, A 0, B 1, 0 into 1 is 0 itself, 1 0 0, 1 1, output high. So these are the basics. By combining these logics, we can have, by combining, say for example, NOT gate and AND gate, we can have NAND gate. Its logic we will see now.